Welcome to Academic Heights. Learn from home. Why Academic Heights? You will get clarity of teaching, clarity in concepts. It covers basics and core concepts for future competency. Your turning point starts here. So today we are seeing objective questions in chapter number 1, real numbers. And all these questions and concepts very important for your board examination. Each and every question is we have covered all core concepts. Means if you know this knowledge, whatever we are solving in this real numbers chapter, that will definitely help you in the board examination. Any question you can do it by your own. So that is the motto of this one. So let us start this very short answer type questions. First of all, first question, very interesting question. A number n when divided by 16 gives remainder 5. Dash is the remainder when the same number is divisible by 8. If we divide with 16, same number with 8, what you will get the remainder? First term he is getting 5 as the remainder. What about if you divide with 8? So this question we can solve by two methods. Same question we can solve by two ways. One is by counter example. Counter example. We'll give one counter example. So 85 I am dividing with 16. Same 85 I will divide with 8. So let us check what happens for this question, for this example. So when we divide 85 with 16, so what you are getting? 16 5s are 80. So you are getting 5 as a remainder. What he states in the question, yes, we are getting the same remainder 5. The same number 85 I am dividing with 8. So this time it goes by 10. 8 tens are 80. So same remainder I got it. Same remainder I got it. So based on the counter examples, we have concluded that so n when divided with 16, it gives remainder 5. The same number when divided by 8 also gives same remainder 5. Next, we can solve by Euclid division lemma also. So what is Euclid division lemma? If a is greater than b, if a is greater than b, a can be expressed as bq plus r, where r is r takes 0 but strictly less than b. So this is, you already know that what is Euclid division lemma. So we will apply for this question. We'll apply for this question. So with n is greater than 16, so n can be written as 16q plus remainder. He has given the remainder here. So what is the remainder he is getting? 5 as the remainder. When we are dividing with 16, you are getting a remainder 5. So same statement I am writing in this way. N is equal to 8 into 2q plus 5. So n is equal to 8k plus 5. So instead of 2q, I can write it as 8k. Anyhow, 2q is an integer, k is also an integer. So when we divide the same number with 8, I am getting the same remainder 8. So this is based on theory and this is based on your counter example. So whichever the way you liked it, you can do in that way. I hope it is clear to everyone. Moving to the next question. Now, in the second question, he is asking about HCF. How to find the HCF. I have given the note in the down of the slide. You can read it. So what is HCF? We have to take common. We have to take common and smallest power of common factors. Smallest power of common prime factors. So this should be very, very important. This should be very, very important. It should be common. Common with the smallest power. So if you observe, so we have two numbers here. This is one number and this is one more number. So in these two numbers, we have common 3 power 3 and 3 power 4. 3 is common here. 3 is an element, it is common. So what we have to take? Smallest power of that common prime factor. So in 3 power 3 and 3 power 4, which is the smallest one? 3 power 3 is the smallest power. So similarly, 5 power 4, we have 5 power 4 and 5 square here. So what is the smallest power of prime factor? That is 5 power 2. So it's a very simple question based on HCF concept. So we should take care about common as well as smallest power. So that's all about this sum. Moving to the next sum. If A is equal to this much and B is equal to this much, where X and Y are prime numbers, then find the LCM of these two numbers. Again, we require the concept how to get the LCM. Just now, second question, we got HCF. In HCF, we saw that we should consider only common factors and smallest powers. But come to the LCM, no need of common factors. Whichever prime number it is involving, we have to take the greatest power of that. So if you look at keenly in this question, so x and x cube, so which is the highest power of prime factor, we have to take that one. X cube is highest. Y square and y cube, highest power of that prime factor, 5 to the power of 5. So this will give your LCM. So once again, if you read it, the product of greatest power of each prime factor, greatest power of each common prime factor. There it is a common prime factor involved in the numbers. This is LCM. I hope it is clear to everyone. Next, this is tree diagram. Earlier we studied about the tree diagram. It's a simple question. Find out X and Y. Suppose I am taking 64. I can write it in this way. This 64, I can write it in this way. I can write 8 8s are 64. Again, this 8 we can write it as 4 2s are. Again, this 4 can be written as 2 2s are. So similarly, same branch you will get it here. You will get 2 4s are. Again, 4 can be written as 2 2s are. So this is, you know, that earlier in smaller classes you know that how to find the factor, tree factor. So whatever we are getting the X value, the product of 5 and 7. The 5 and 7, the product will give the X value. Suppose here we have 2 2s are 4 we are getting. So we are getting this into this is 4 2s are 8 we are getting. 2 4 8 we are getting. 8 8 just 16 we are getting. In the similar way, so what is the product? So this product will give the x value. So 5 7 is 35. So x is 35. Again this product 2 into 35 will give the value of y. So this is 70. A very simple sum. We can do it easily. We can understand easily. Next question. Question number 5. If n is a natural number, then 25 to the power of 2n minus 9 power 2n is always divisible by. So how to solve this question? So 25 to the power of 2n minus 9 to the power of 2n. So I can write it is in the form of in this way. A power mn can be expressed as a to the power of m whole power n also. So we have already studied in exponents. A power m whole power n is equal to a power mn. Similarly, I can split this in this way. 25 to the power of n whole square minus 9 to the power of n whole square, I can write. So this is in the form of a square minus b square. So what is the identity? A square minus b square, a minus b into a plus b. You know this identity. So this can be written as 25 power n minus 9 power n into 25 power n plus 9 power n. Now we will check. So what is n here? N is a natural number. So in the given data he has created a natural number. So just I will take the value of n. I will take the value of n is equal to 1. So n is equal to 1. So what I will get it? 25 minus 9 and 25 plus 9. So that number we got it as 16 into 34. 16 into 34. The same number 25 to the power of 2n minus 9 power 2n. So what we got it as 16 into 34. So it is obviously, we can see that, so it is divisible by both 16 and 34. Suppose we can go for n is equal to 2 also. Check for n is equal to 2. So in this I'm writing, in this equation I'm writing n is equal to 2. So what I will get? 25 to the power of 2. Here n is 2, here n is 2, here n is 2, here n is 2. 25 power 2 minus 9 power 2 into 25 power 2 plus 9 power 2. So again this can be written as 25 minus 9 and 25 plus. I have applied a square minus b square formula. I applied this formula. So this is as it is, 25 square plus 9 square. So whatever I'm getting here, it is again 16 into 34 into this much number, 25 square plus 9 square. So same number, again I can write it as in the form of 16 into 34 into something else. So here it is 16 and 34. It is a common factor for value of n, so that we can decide it. We can decide that this number is divisible by both 36 and 34 and 16.